This is lesson 4.5, compare properties of functions. What you're going to see is that even though we're introducing some new information here, it's going to look very similar to things that you've done already, which should be encouraging. And again, with the success that we've been having so far in Chapter 4, hopefully this will allow us to continue to build on that, and I'm looking forward to the Chapter 4 assessment being the best that we've had so far. I know you're looking forward to it as well. So take a couple of minutes right now to do the quick check on your own. It says use the make a table strategy to solve exercises 1 and 2. There are a couple of different ways to do it. You could also use guess and check, but see if you can make tables to answer questions 1 and 2. When you're ready, please come back and review the answers to the problems. So for question number 1, we should have 70 jumping jacks. If you create a table and work your way backwards, you'll notice that the values for jumping jacks are decreasing by 5 as the weeks go back. So in week 3, he would do 70 jumping jacks. For example number 2, we would be working forward. So if you start with $25 and save $250 a week, week 1 you'd have $27.50, and that pattern would continue to increase by $250 until you get to week 7. So we're looking at week 7 or the 7th week for number 2. The essential question, as always, how can we model relationships between quantities? So looking at how some different things in terms of functions are going to be related to each other. Today's I can statement is I can compare two functions represented in different forms. And what we're going to see is that whether we have an equation, whether we have a table, whether we have a graph, or whether we have something written in words, we're going to be able to make some comparisons and then draw some conclusions based on the information that we have. So, example 1, we have a zebra's main predator is a lion. Lions can run at a speed of 53 feet per second over short distances. The graph at the right shows the speed of a zebra. Compare their speeds. So, it does not tell me what the speed of a zebra is. I'm going to determine that from the graph that they gave me. And we're going to do that in the following steps. First, you need to find the rate of change for each situation in order to be able to compare them. Well, they already gave me the fact that a lion's speed is 53 feet per second. So I already have that. What I want to do is determine from the graph the rate of change of the zebra, because they told me the zebra is the graph. So I'm going to do this finding the rate of change, which is just the slope of the line. So we're going to do this the way that we've done any other slope, which is to pick any 2 points on the line, subtract the y's, subtract the x's, and divide them. So it's going to look like, a lot of times it's easiest to just take the 2 closest points right here. So I'm going to take this 1, 59, and I'm going to take this 2, 118, excuse me, and I'm going to get after that. So the slope in this case should be 118 minus 59 over 2 minus 1. And that gives me 118 minus 59 is 59. 2 minus 1 is 1. 59 over 1 is 59, which means that the rate of change for the zebra is 59, aka 59 feet per second. Okay, so as long as we're comparing the same units. So compare and conclude. What does it say? Compare their speeds. Well, the lion's speed is 53 feet per second, and the zebra's speed is 59 feet per second. So compare and conclude, I'm going to write a sentence here. That's going to include all of that information. And I could kind of, put it into one sentence. So the zebra is about the zebra's speed is 59 feet per second, which is faster than the lion. Is that good enough? They already told me what the lion's one is, so I don't have to repeat that. But the two things I had to do was calculate the lion's rate of change, in this case his speed, and then compare that to the lion's speed. So zebra's faster. I bet you didn't know that. Zebra's faster, and there you have it. So if you can try example part 1A, I guess we're calling it. Try this one by yourself and get back to me when you are done. So based on the calculations here, again, I'm going to find the slope of this line by using any of the 2 points. Technically, you could have used 0, 0. That would have been fine. I chose these 2 points, which gives me 240 minus 120 over 4 minus 2. That gives me 120 over 2, which divides to 60, and that's gallons per minute. So it's 60 gallons per minute, and this was the koi pond over here in the graph. So comparing the 60 that I've solved for to the 52 that I was given, the flow rate of the koi pond is 60 gallons per minute, which is faster than the water garden. If you have any questions or weren't sure about that, feel free to back up now and catch up, do it over. Otherwise, we're going to move on to example number 2. The function m equals 140h, where m is the miles traveled in h hours, represents the speed of the first Japanese high-speed train. The speed of a high-speed train operating today in China is shown in the table. So I've got equation here, table there. Assume the relationship between the two quantities is linear. Okay, so compare the functions y-intercepts and rates of change. Okay, so first of all, when something like this has time as one of the factors, it is safe to assume that we're going to start at 0 minutes or 0 seconds or 0 whatever the units of time that is being measured. So you could also safely assume that at a time of 0, neither train has started yet, so they have not covered any miles at all, which would mean that this point number 1, when time is 0, the trains have traveled 0 miles. So what does that mean? It means the y-intercepts are both 0. So if I was going to graph this, which I'm not, but if I did, the origin would be the y-intercept for both of these lines. They would both start at 0, 0. So that's the first part. It says compare the y-intercepts. Okay, I just did that. The Japanese train has a rate of change of 140 miles per hour based on the equation m equals 140h. So remember this here, the number in front of the letter is the coefficient, which indicates the slope. And it says you can find the rate of change of the Chinese train from the table. So just like in the previous example, we had to do a little work to get the rate of change from the graph. We're going to do the same thing here from the table. So again, you can treat these like ordered pairs. And what I'm going to do is, again, find the slope of the line that would include these. So I'm going to subtract the y's and I'm going to subtract the x's. Put the y's on top and the x's on the bottom, and I'm going to divide and see what my slope is going to be. So wherever you have room. So we're going to need to subtract these two, 434 minus 217. On top, 2 minus 1 on the bottom. Hopefully you can see that it's going to be 217 over 1, which is going to give me 217 miles per hour. Quite a bit faster than 140, wouldn't you say? So compare and conclude. Again, this is going to be my conclusion sentence, very similar to what I did before. And we're going to say, make sure we're answering the questions. Compare the functions y-intercepts and rates of change. So we compared the y-intercepts. The y-intercepts are both 0. And then we're going to compare the rate of change. Okay, so I already know that, well actually, see, because it's in an equation, I actually have to tell what the rate of change is. So that's exactly what I'm going to do here. The Japanese train, and again, in the context of the problem, Japanese train, we're talking about speed, right? Rate. The Japanese train travels at 140 miles per hour. Chinese train, excuse me. And normally when you hear the word compare, I'm telling like, you know, which one is better or which one is faster in this case. So I'm probably going to make mention to that. Travels at 217 miles per hour, which is faster, obviously. Okay, so Chinese train is faster. Part B of this, if you ride each train for 5 hours, how far will you travel on each? Okay, so now here's the thing. Substitute 5 into each equation. I don't have an equation for the Chinese train. I do have an equation for this one, for the first one, this is Japanese, this is Chinese, so I do have one for the Japanese, 140 times 5, that's all I'm going to do. M equals 140 times 5. Which should be 700 miles. Now, here's the deal with the other one. You can see that this pattern is going to continue to increase. Well, obviously then the rate of change is 217, so my equation here should be y equals 217x, right? Or in the letters that they're using would be m equals 217h, if you want to get technical about it. But I'm going to do the same thing. I'm going to substitute 5 in for the variable here, which would be the h. So same idea, substitute it into the other equation. I'm just going to copy and paste, change my values here. $217 times 5. Which is 1,085 miles, 1085. So there they are. If you ride each train 5 hours, how far you travel on each? So on the Japanese train, you're going to go 700 miles. On the Chinese train, you're going to go 1,085 miles. Okay? Back that up and go over it again if you need to. Otherwise, please try this example on your own. So, of course, the example is a little different than the one that we did. The one that you're trying by yourself is different than the one that we're doing on your own. I just said the same thing, didn't I? They're different. At any rate, a bowling alley offers different birthday party packages. Package A is 7p plus 5. Package B, from the table you can decipher that it's going to be 9p. Multiply by 9, multiply by 9, multiply by 9, multiply by 9, right? So, compare the functions by comparing their y-intercepts. All right, this is the y-intercept of the first equation, the plus 5. So that intercept is at 5, which means probably that there's a $5 fee no matter what, okay, for rental or whatever. Over here, there is no intercept. It would be plus 0, so the intercept at package B is 0. So that's exactly what I'm going to say. The y-intercept for package A is 5, and for package B it is 0. So they're different, first of all. There is no $5 fee here, but there is over here in the context of the problem. Part B, how much more will package B cost than package A if there are 12 people at the party? So I need to substitute 12 into P for both situations. If I do that for the first situation, I get 7 times 12 plus 5, which gives me 84 plus 5 is $89. For package B, I insert 12 for P, and it's 9 times 12 equals 108. So then I need to take these two values and subtract them. 108 minus 89 is 19, so package B is $19 more expensive. All right, if you need to go over that again, please rewind now and do that. Otherwise, we're moving on to the next example, example 3. Financial literacy. Angela and Benjamin each have a monthly cell phone bill. Angela's monthly cell phone bill is represented by the function y equals 0.15x plus 49, where x represents minutes and y represents cost. So in other words, it looks like it's 15 cents per minute plus $49 fee per month is probably how I would decipher the context of this situation. Benjamin's monthly cost is shown in the graph, so I'm going to, again, do some determining factors here to figure out what that is. Compare the y-intercepts and rates of change. So you can see that the basic information that they're asking for is the same in every type of problem, no matter what information is provided in terms of graph, table, equation. All right, they're always asking for the same thing. Rate of change, y-intercept, compare them, tell which one is faster, slower, more expensive, you get the idea. Okay, so first of all, the y-intercept in the equation up here, this is 49. How do I know that? Because that's the b, that's the y-intercept of an equation written in slope-intercept form. From the graph, you can tell that the y-intercept is 60. What do you mean? Well, there it is right there. The line is crossing the y-axis at 60, which means Benjamin probably has a $60 monthly fee plus whatever his minute charge is. Find the rate of change of the graph. So again, I'm going to find the slope. Pick any 2 points and find the slope. And I'm going to do that by, in this case, subtracting 72 minus 60 on the top, because those are the y values. On the bottom, I'm going to be subtracting 120 minus 0. Oops. 0. So 72 minus 60 is 12. 120 minus 0 is 120. Okay, now I got to think of this in terms of a couple of different ways. So 12 over 120 is going to be 1 over 10, right? So my slope is going to be 1 over 10, meaning 1/10, which means 0.1, which means that in the context of dollars and cents, it's 10 cents per minute versus 15 cents per minute. Do you see the difference? Okay, so find the rate of change here. Answer based on the context of the situation. So compare the y-intercepts and rates of change. Based on the context of the situation, this is the minute charge, like how much it costs per minute. This is going to be the monthly charge, the monthly fee, no matter what. So 60 is the monthly fee of Benjamin's, 49 is the monthly fee of Angela's. So Angela's paying $49 plus 15 cents a minute. Benjamin is paying $60 plus 10 cents per minute. Does that make sense? I hope it does. And hopefully within the context of cell phone bills, it really makes sense, because a lot of you probably are either paying for your own cell phones by now, or at least you see what the bill looks like. So answer based on the context. Angela pays $49 per month plus 15 cents per minute. And Benjamin pays what? Benjamin pays $60 per month. Plus 10 cents per minute. So not only did I do the necessary mathematics that I did, but I also put it in the context of the problem. All right, whoops, don't want to move that around. What will be the monthly cost for Angela and Benjamin for 200 minutes? Okay, substitute 200 for x in both situations. I have this equation for which I can substitute 200 in, which is what I'm going to do. So this is Angela's. Y equals 0.15x plus 49. And I'm going to sub in the 200 for x. So y equals 0.15 times 200 plus 49. Can you do this mentally? Y equals 200 times 0.15. Basically, what is 15% of 200? Should give you 30. Plus 49, which is going to be $79. Just verifying with my calculator. And I am right. So $79 for Angela for 200 minutes. Now, Benjamin. I don't have an equation for him. I could come up with one. In fact, based on my words here, it would be y equals 0.1x plus 60. Or can't we just look at the graph? Here's 200 minutes right here. There's 200. Let's go all the way up. And voila, it gives me the ordered pair of 200, 80. That means for 200 minutes, it's going to cost $80. So Benjamin is going to pay $80. What will be the monthly cost for Angela and Benjamin for 200 minutes? Well, Angela is going to pay $79, and Benjamin is going to pay $80. So pretty close. $80. Okay, and there you have it. So again, take a look back through that if you have questions. It's really just straightforward calculations, getting information from here. If you don't have questions or you don't need to replay that, then please try the next example on your own. All right, so again, don't flip out, but the independent example is a little bit different from the one that we did together. So hopefully the idea is that you understand based on the situation or circumstance, you're going to be able to do these types of problems, okay? So at any rate, they give us the equation for the first company, and then they give us a graph for the second company. Compare the y-intercepts. All right, so from the equation, again, this is the y-intercept of the first company, which is 5. What's the context of that? $5 fee. From the graph, the y-intercept is 4. What is the context of that? That means it's a $4 fee. So the first company charges a $5 fee and the second company charges a $4 fee. That's the y-intercept in the context of the problem. Secondly, what will be the cost from each company if 15 movies are rented in 1 month? The first one, in my opinion, is easy because they gave you the equation. All I have to do is substitute 15 in for M. So if I do that, I eventually calculate to $27.50. Over here, you have to use some knowledge from chapter 3. I can find the equation of this line. Here's the y-intercept at 4, and if I go, notice that these units here are going up by 2. So technically this is up 2 and over 1, up 2 over 1, up 2 over 1. So my slope should be 2. There's my equation, y equals 2x plus 4. In the context of this, using c and m as my variables, c equals 2m plus 4. So I'm going to substitute 15 in for m in that equation, which gives me 30 plus 4 equals $34. So my conclusion statement then is the cost is $27.50 for the first company and $34 for the second. You may want to go back and review that again. It was a little fast, and again, there are a lot of things that, again, the book expects you to know from chapter 3, that if you need to polish up some of those skills, then that's necessary. If you have questions about this example, please ask. Otherwise, we are moving on to example 4. Example 4, Lorena's mother needs to rent a truck to move some furniture. The cost to rent a truck from 2 different companies is shown in the table, this one down here, and in the graph, this one up here. So these are 2 different companies. Which company should she use to rent the truck for 40 miles? So there's a lot implied here in this problem, and they don't give you specific instructions as to what to do. So you're going to need to be able to solve problems like this, obviously, in a certain manner. So what we're going to do is, if you've noticed so far, we're always trying to compare the same types of information. So it makes sense if we have this table here. You could do it one of 2 ways. When you have a table and a graph, you either need to turn this table into a graph, which is probably going to take quite a bit more time, or we can turn this graph into a table, which I've started to do over here. And as long as we're comparing the same things, it's a little bit easier to see what's going to happen. So the first thing we need to do is create a table from both situations. This one has already started for us, so we're just going to continue. You can see what the pattern here is happening, and we should also keep it in the context of the problem, which mentions that it wants to know which company is best for 40 miles. So we're going to want this table to go up to 40, and we're going to want this table to go up to 40, so that we're comparing the same things. So that being said, let's go ahead and finish off this table down here. I know it's not going to be the prettiest looking table in the universe, but that's not necessary right now. So there's my 30 and 40. And if you look at the pattern, you can look at it one of 2 ways. Either the cost is increasing, it looks like in increments of 25, or going across from miles to the cost is times 2.5 each way. So if you look at it that way, this pattern is obviously going to repeat, and it's going to be 75 and 100 as far as the cost is concerned. So this is going to be $75, and this is going to be $100. And that's for Ron's Rentals, excuse me. So this table's done, and it looks like I also have information that's going to be helpful in terms of solving or answering the question, rather, which is which company should she use to rent the truck for 40 miles, presumably the one that's going to cost her less money. So we're done with the first one. We need to now attack the crosstown movers and take this information from the graph and put it into another table that looks just like this one, so that we're comparing the same things. So from a miles standpoint, it looks like from the graph we can determine 10 miles is going to cost her $35. And we can actually get a 20 and a 30 and a 40 so that the tables look the same, and I'm comparing sure you've heard the phrase comparing apples to apples. That's what we want to be able to do here. The same type of units each way. So you can see based on the ordered pair they give me that it's $35 for 10 miles. I'm just going to copy and paste some of this information over here. So 35, and then if you look, 30 miles is going to cost $45. So I'm going to put in the 45 opposite that, which means that I have a couple of blanks to fill in. So 10 miles is going to cost me $35. 30 miles is going to cost me $45 right now. From the graph, now it doesn't show you with an ordered pair, but you can see that for 20 miles, this is right on this line right there, which appears to coincide with $40. So that can help us also in terms of our pattern. And it looks like, based on our table, these are increasing by 5. Okay? Increasing by 5 each time, which means that for 40 miles, it's going to cost $50. And you can kind of see where the trend line is going here. By the time this gets up to, this gets to 40 miles, it looks like that's going to intersect right at $50. So here's what we've done. We created this table for Ron's Rentals, filled it in. We created this table for Crosstown Movers with the information from the graph. Step 3 then is we're going to compare. Well, you tell me. There's my 40 miles for this table and 40 miles, half as much, right? So answer based on the context of the situation. She should use Crosstown Movers. And then we usually want to put a Y along with this. So Lorena should use Crosstown Movers because, and you can, use some insight here. 50 is half of 100, so because it's going to cost her half as much. That definitely shows me that you know what you're talking about and you did the problem correctly. If you can, in your conclusion statement, say that Lorena is going to pay half as much for Crosstown Movers. So that's how we compare information that's given to us in 2 different presentations. We make one presentation look like the other one and then compare apples to apples, so to speak. So go ahead and play that back if you need to, and when you're ready, please complete the last example on your own. So again, we want to make sure that we're comparing like visuals. There is an equation here for subs and a table here for pizzas. From the table for pizzas, you could determine that each of these is being multiplied by 5, which means that's the rate of change. So in other words, $5 per pizza. Doesn't say what the size of the pizza is, but that sounds like a pretty good deal. And then for subs, it's M equals 4S, which means $4 per sub. So you probably already know that if it's $5 versus $4, if they're trying to earn money, the one that is $5 per item is going to make them more. But kind of bouncing ahead a little bit, you would want to set up a table with subs or determine an equation with pizzas. So certainly nothing wrong with looking at this table and identifying that the constant rate of change is 5 and saying, okay, well that means that for pizzas, my situation is M equals 5. Actually, I mean, it's probably better off doing it this way, because up here it says that M represents money earned and S represents the number of subs. So maybe you want to say P for pizza and say that money earned equals 5P for pizza. And then you're still comparing, things that are the same, because now you're looking at M versus 4 times a variable versus M times 5 times a variable, and this is obviously going to make you more money. Or obviously make a table with the subs 20, 40, 60, 80, 100 so that you're comparing the same amount of stuff, and then times 4 times 4 times 4 times 4 times 4 gives you the cost, and obviously $500 earned is better than $400 earned. So either way you look at it, students will earn more money by selling 100 pizzas. Okay? Again, if you have questions with that, play it back again, ask me if you need help, otherwise we're moving on. So what you saw today hopefully is that functions are represented in different ways. table graph equation words and can be compared, and you want to compare them. If you have two different things, you want to make them both the same somehow so that you are comparing, as we said, apples to apples. You can find slopes of different functions to be able to compare rates of change. Rate of change and slope is the same thing. Hopefully after seeing chapter 3 and chapter 4, you understand that rate of change means slope. It's the same thing. Rate of change is used more commonly with these real-world problems that we've been looking at, specifically like in this lesson today. You can find y-intercepts of different functions to compare initial values. We had a couple that were both at 0. We had ones where one was a $45 fee and the other was a $60 fee. So those can also help you in terms of what the line is going to look like. Right now you should be working on guided practice, page 314, numbers 1 through 3. When you are finished with that, please check it with the book in the front table. If you have any questions about anything, seriously, let me know. You guys have been doing a great job so far overall. Please maintain that success, doing the right things, and avoid doing the wrong thing. It's really common sense. Continuing to do the right thing is going to continue to lead you where you want to go. And then obviously choosing to do the wrong thing is going to take you places that you don't want to go. So check your guided practice first after having completed it with the book in the front. And then by then you should probably have a little bit of time to start on your homework, which is page 315. And IXL skill Z11 in the 8th grade tab is supplementary to this. So hopefully this lesson was effective for you. Play back anything that you missed in order to clean up any problem areas. And then obviously ask for help if you need it. Okay? Have a great day.